today is that we are going to learn by the end of the lesson how to find the derivative of sine, cosine, and tan functions, modeling the harmonic motion, jerk as the derivative of acceleration, and defined how we can find the derivative of the velocity and from the distance, and derivative of the acceleration from the velocity, and finally the derivative of the jerk from the acceleration. And derivatives of the tangent, cotangent, secant, and cosecant of the function, which known as tan, cotan, sec, and cosec of a function, and also find the equation of the tangent and normal line. And why? Because the derivatives of the sine and the cosine play a key role in the describing the periodic change, anything related to a measure of an angle or the derivative of a function that represented by a sine or cosine curve. First, we should note that the derivative of the sine function, the derivative of the sine function is a cosine. Derivative of sine is cosine. For example, if y is equal 3 sine x, notice that 3 is a constant outside the function, then dy by dx is equal 3 cosine x. 3 cosine x. Another example. If y is equal to x sine x, and we can notice here that x sine x is a product rule, and the derivative of the product rule is derivative of the first multiplied by the second plus derivative of the second multiplied by the first. So I can say that dy by dx is equal derivative of the first, which is 1, multiplied by the second, which is sine x, plus derivative of the second, which is cosine x, multiplied by the first, which is x. So the final answer is sine x plus x cosine x. So it's a very important notice that x sine x, it's not only one function, it's a product rule of derivative. Or if I wanted to find the derivative, I should use the product rule techniques. The second rule is the derivative of cosine x, and the derivative of cosine x is negative sine x. The derivative of cosine x is negative sine x. Notice that it's negative, it's not a positive. And to prove this rule, or why the derivative of the cosine is equal negative sine, we can apply the rule for the limit of h tends to 0 for f of x plus h minus f of h divided by h when x tends to 0. You will find it in your book, page 142. But directly you are going to use that the derivative of the cosine of x is equal negative sine x. Example 1. If y is equal to 5 cosine x, then dy by dx is equal the constant, and the derivative of cosine is what? Is negative sine, so it's going to be negative 5 sine x. Negative 5 sine x. 5 is a constant, so I'm not going to use the product rule. But notice that in example 2, if y is equal 5x cosine x, then I have to use the product rule, as 5x is a function in terms of x and cosine x is another function. So d by dx for the product rule is u dash v plus v dash u. So dy by dx is equal derivative of the first, which is 5, multiplied by the second, plus derivative of the second, which is negative sine x, multiplied by the first, which is 5x. So this one can be written as 5 cosine x minus 5x sine x. Later, if you think of simplified more or taking 5 as a highest common factor, it's going to be cosine x minus x sine x. And this is the simplest form of the dy by dx, or the derivative of y. Example for the simple harmonic motion. A weight hanging from a spring pop ups and down with a position function s is equal 3 sine t. So we can define s here as the distance meter and t is the time in second. So s is equal 3 sine t. Find the velocity and the acceleration. To find the velocity and the acceleration from a given distance, the definition of velocity is the derivative of the distance with respect to time. And the definition of the acceleration, as we know, is the derivative of the velocity with respect to time. So velocity is a first derivative of the distance, and acceleration is the second derivative of the distance, or we can say that the acceleration is the derivative of the velocity with respect to time. So if I wanted to find the velocity, I'm going to find the derivative of 3 sine t with respect to t, with respect to the time, with respect to the time. So velocity is equal ds by dt, which is 3 cosine t, which is 3 cosine t. As we said before, that the derivative of sine is equal to cosine. And if I wanted to find the acceleration, I'm going to find another derivative for 3 cosine t. Derivative of 3, it's a constant, so it's a 3, and derivative of cosine is negative sine. So don't forget that d by dx for sine x is cosine x, and d by dx for cosine x is negative sine x, negative sine x. If I wanted to find the jerk is the derivative of the acceleration, and this is if a body is moving position at time t. So if I wanted to find the jerk of a movement of a body, I gotta derivative or find the derivative of the acceleration. The last example, the acceleration was negative 3 cosine t. So if I wanted to find the jerk at t, I'm going to divide the derivative with respect to t for negative 3 cosine t. So negative 3 is a constant, and derivative of cosine is sine. So it's negative 3 sine t, negative 3 sine t. Derivative of the other basic trigonometric functions. The derivative of tan is sec square. Derivative of cotan is negative cosec square. Derivative of sec is sec times tan. Derivative of cosec is negative cosec times cotan. So if we add here d by dx for sine x is going to be cosine x, and d by dx for cosine x, which is negative sine x. So these are the 6 trigonometric functions, or the 6 derivative of the trigonometric functions. Derivative of sine is cosine, derivative of cosine is negative sine. Example for the tan, if y is equal to 3 tan x, and I wanted to find dy by dx, so dy by dx is 3 sec square x. 3 sec square x, as 3 is a constant. Example for the sec y is equal to negative 5 sec x. So dy by dx is equal, negative 5 is a constant, and the derivative of sec is sec x tan x. It's a product between the sec and the tan. Number 1, y is equal 1 plus x minus cosine x, and I wanted to find dy by dx. Derivative of 1 is 0, derivative of x is 1, minus derivative of cosine is negative sine x, so negative multiplied by negative is positive, so it's 1 plus sine x. 1 plus sine x. Number 2, y is equal to sine x minus tan x. So dy by dx is equal to derivative of sine is cosine x minus derivative of tan is sec square x. Number 3, y is equal 1 over x plus 5 sine x, which can be written as x to the power of negative 1 plus 5 sine x. So dy by dx is equal negative 1x to the power of negative 2 plus 5 derivative of sine is cosine x. Number 4, y is equal x sec x. So we are going to use the product rule, d by dx for u. V is u dash v plus v dash u. So dy by dx is equal, derivative of x is 1 multiplied by sec x, plus derivative of sec is sec x times tan x multiplied by the first, which is x. So it's a sec x plus sec tan x. So I wanted to find dy by dx for 4, which is 0 as it's a constant, and x square minus or multiplied by sine x, this is a product rule, and the derivative of the product rule is u dash v plus v dash u. So I will consider negative x squared as a whole function. So derivative of the first, which is negative 2x multiplied by the second, plus derivative of the second, which is cosine x multiplied by the first. So it's going to be written as negative 2x sine x minus x squared cosine x. This is dy with respect to x. Dy over dx. The derivative of 3x is 3. And x tan x, this is a product rule. So it's a derivative of the first multiplied by the second, which is 10x, plus the first multiplied derivative of the second, and derivative of tan x is 6 square x. So it's a 3 plus 10x plus 6 square x. Y is equal 4 over cosine x, and this is a quotient rule, and we know that derivative of u over v is equal to square of the denominator and u derivative of u, which is u dash multiplied by v minus v dash multiplied by u. So dy over dx is equal squaring of cosine x, so cosine x square, then derivative of 4, which is 0, multiply the denominator, minus derivative of the denominator, which is negative sine x, multiplied by the numerator. Let's simplify it. 0 multiply anything is 0, negative multiplied by negative is positive, so it's a positive 4 sine x divided by cosine square x. By the way, you can write it as 4 sine x over cosine x multiply cosine x, and sine over cosine is tan, so it's a 4 tan x, and 1 over cosine is sec x, so you may find 4 tan x sec x in the choices. Okay, y is equal x over 1 plus cosine x, and I wanted to find the derivative of y dy by dx with respect to x for the functions, whereas it's a quotient rule, and we know that d by dx for the quotient rule u over v is equal squaring of the denominator u dash v minus v dash u. So dy by dx is equal 1 plus cosine x square, then derivative of x, which is 1, multiplied by the denominator, minus the numerator multiplied by derivative of the denominator, which is negative sine x. So 1 times 1 is 1. 1 times cosine is cosine x, minus negative multiplied by negative is going to be positive, x sine x over 1 plus cosine x all to the power of 2. dy by dx is equal, as we know that the derivative of the quotient is u dash v minus v dash u over v square, so it's 1 plus cotan x square, and then derivative of cotan is negative cosec x square multiplied by the denominator, which is 1 plus cotan x, minus derivative of the denominator, which is negative cosec square x multiplied by the numerator, which is cotan x. So it's equal to 1 plus cotan x all to the power of 2. Negative cosec multiplied by 1 is negative cosec square x minus cosec square x cotan x. Negative multiplied by negative is positive cosec square x cotan x, so it's equal to 1 plus cotan x square. By cancelling the adding of the like terms, negative cosec and positive cosec give me 0, so it's negative cosec square x. So this is dy by dx. Y is equal cosine x over 1 plus sine x. d by dx for the quotient rule is v square u dash v minus v dash u. This is u, this is v. So dy by dx is equal the denominator to the power of 2, which is 1 plus sine x to the power of 2. Usually we don't expand the bracket in the denominator here. Derivative of cosine x is negative sine x multiplied by the denominator, which is 1 plus sine x, minus derivative of the denominator, which is cosine x multiplied by the denominator, which is sine x, multiplied by the numerator, which is cosine x. So it's equal negative sine multiplied by 1 is negative sine x, negative multiplied by negative is positive, sine by sine is sine square x, minus cosine by cosine is cosine square x over 1 plus sine square x square. So by taking negative here as a highest common factor, I have sine square x plus cosine square x, and here is negative sine x, so it could be written as negative sine x minus 1. By taking negative as a highest common factor, it's 1 plus sine x over 1 plus sine x all square. By cancelling one of the power, the final answer is negative 1 over 1 plus sine x. So I used one identity, the identity of sine square angle plus cosine square angle is equal to 1. And here I used highest common factor, which is negative 1, and the same here I used another highest common factor. And these are the steps of simplifying.